What if Earth's air was twice as thick? Imagine waking up tomorrow to the rumble of your neighbor's car engine sounding like a freight train thundering past your window. Every footstep echoes with unusual resonance. Every whisper carries further than before, and the familiar hum of the world around you has transformed into something deeper, more visceral. This is your first clue that something extraordinary has happened to our planet. Earth's atmosphere has doubled in thickness overnight. As you step outside, the air itself feels different. Not just the sound, but the very texture of breathing. Each breath delivers twice the oxygen molecules your body is accustomed to, while atmospheric pressure presses down on you with 29.4 pounds per square inch instead of the familiar 14.7. The sky above appears hazier, thicker, like looking up through water rather than air. Welcome to Earth 2.0, where the laws of physics have been rewritten by a simple doubling of atmospheric mass. The first hour. Chaos in the thick air. Within the first hour, the most dramatic changes would be biological. Every living creature on Earth would suddenly find itself in a hyperoxic environment containing roughly 42% oxygen instead of our normal 21%. For insects, this would trigger an immediate and remarkable transformation. Like time-lapse footage of evolution, flies and beetles would begin swelling in size as their tracheal breathing systems, no longer constrained by oxygen scarcity, could suddenly support much larger bodies. Think of it like upgrading from a garden hose to a fire hydrant. The same breathing tubes that once limited insect size could now deliver torrents of oxygen to massive bodies. Within hours, we might witness the return of giants reminiscent of the Carboniferous period, when dragonflies with 28-inch wingspans ruled skies rich with 35% oxygen. But humans would face immediate challenges. The doubled pressure would force twice as many gas molecules into our lungs with each breath. Initially exhilarating, like the rush of pure oxygen, this hyperoxic state would quickly become dangerous. Studies show that even modest increases in atmospheric pressure can cause nitrogen narcosis, a dangerous intoxicating effect that impairs judgment and motor skills. At double atmospheric pressure, we'd be breathing the equivalent of air at 60 feet underwater, triggering symptoms similar to alcohol intoxication within minutes. The physics of sound would transform our world into an acoustic wonderland. In this denser medium, sound waves would travel with greater intensity and carry much farther. A whispered conversation could be heard across a room, while a shout might carry for miles. The extra air molecules would create a richer, more resonant soundscape, like the difference between speaking in a closet versus a cathedral. The first day, a planet transformed. By the end of the first day, the cascading effects would reshape our planet's fundamental systems. The doubled atmospheric mass would create a greenhouse effect of unprecedented magnitude. With twice as many heat-trapping molecules in the air, Earth's surface would begin heating rapidly. Scientists estimate this could trigger temperature increases of 40 degrees Celsius, 72 degrees Fahrenheit, or more, potentially initiating a runaway greenhouse effect similar to what transformed Venus into a hellish furnace. The oceans would respond dramatically to this temperature spike. Evaporation rates would skyrocket, as the warmer air could hold vastly more water vapor. Picture the water cycle as a massive engine suddenly running at double speed. The oceans, which normally contribute 86% of global evaporation, would pump enormous quantities of moisture into the thickened atmosphere. This supercharged water cycle would spawn storms of incredible intensity, as twice the atmospheric density would provide more energy and material for hurricane and tornado formation. Weather patterns would become increasingly violent and unpredictable. The fundamental physics of storm systems depends on air density, pressure differentials, and the energy available in atmospheric circulation. With double the atmospheric mass, these storms would carry twice the punch. Imagine hurricanes with the energy density of thermonuclear explosions and tornadoes that could flatten entire cities. Flying creatures would experience this new world as both blessing and curse. The increased air density would provide much more lift, making flight easier for birds and insects. However, this advantage would come at a cost. The denser air would also create significantly more drag, requiring more energy to maintain speed. Small birds might find themselves able to hover effortlessly like hummingbirds, while larger birds would need to completely rethink their flight strategies. The long-term evolution in fast forward. Over the following weeks, months, and years, life on Earth would undergo one of the most rapid evolutionary transformations in planetary history. The hyperoxic environment would trigger massive changes in the animal kingdom, particularly among insects and other arthropods. We would witness the return of giants not seen since the Permian period 300 million years ago. Dragonflies could grow to the size of eagles, with wingspans exceeding 6 feet, just as their ancient ancestors did when oxygen levels reached 35%. Beetles might achieve the mass of small mammals, while spiders could grow large enough to hunt birds. This isn't science fiction, it's evolutionary biology responding to atmospheric chemistry, exactly as it did in Earth's prehistoric hyperoxic periods. However, larger life forms, including humans, would face an existential crisis. The excessive oxygen would become toxic over extended exposure, causing cellular damage through oxidative stress. Our lungs, evolved for 21% oxygen, would struggle with the hyperoxic environment. We'd need to develop protective measures, perhaps breathing apparatus that filtered the air back to normal oxygen concentrations, or genetic adaptations that our descendants might evolve over millennia. The climate would stabilize into a new, much hotter equilibrium. With double the greenhouse gases and water vapor in the atmosphere, Earth might resemble the Paleocene-Eocene thermal maximum, a period 55 million years ago, when global temperatures averaged 90 degrees Fahrenheit compared to today's 59 degrees Fahrenheit. Sea levels would rise dramatically as thermal expansion and melting ice sheets added water to oceans supercharged by the enhanced greenhouse effect. Plant life would flourish in this carbon dioxide and oxygen-rich environment, creating vast forests of unprecedented size and density. However, the increased atmospheric pressure would also make wildfires burn with terrifying intensity, as the oxygen-rich air would fuel blazes that could consume entire continents. A new Earth's equilibrium. In our doubled atmosphere world, Earth would emerge as a planet both magnificent and terrifying. The fundamental relationship between life and atmosphere that has governed evolution for billions of years would shift dramatically, triggering changes that would reshape every ecosystem on the planet. The key insight from this thought experiment is how delicately balanced our current atmosphere truly is. That familiar 14.7 pounds per square inch of pressure, that precise 21% oxygen content. These aren't arbitrary numbers, but the result of billions of years of coevolution between life and atmosphere. Change them, and everything changes. Perhaps most remarkably, this scenario isn't entirely hypothetical. Earth has experienced similar atmospheric compositions before. During the Carboniferous period, when oxygen levels soared to 35%, our planet did indeed host giants, massive dragonflies, 2-meter millipedes, and forests of towering trees. The geological record shows us that life doesn't just adapt to atmospheric changes. It thrives, evolves, and creates entirely new forms of existence. But here's the mind-blowing final thought. In our doubled atmosphere Earth, while humans might struggle to survive, life itself would explode into forms and sizes we can barely imagine. We might witness the emergence of flying creatures the size of small aircraft, forests so dense they create their own weather systems, and insects that could serve as beasts of burden. In doubling our atmosphere's thickness, we wouldn't destroy life on Earth, we'd unleash its most spectacular potential, creating a world where the impossible becomes inevitable, and giants once again rule the skies. Which scares you more, giant insects or yearly superstorms? Tell us in the comments. If this changed how you see the world, subscribe and join the Curiosity Collective. If you want more mind-bending questions, check out our other videos. For steady, practical wisdom, visit my other channel, A Stoic's Handbook. Stay curious. Question everything.